This is section 3.1. Computing the mean of a data set. Compute the median of a data set. Compare the properties of the mean and median. Find the mode of a data set. Approximate the mean with grouped data. And compute a weighted mean. The mean of a data set is a measure of center. If we imagine each data value to be a weight, then the mean is the point at which the data set balances. Recall that a population consists of an entire collection of individuals about which is sought, and a sample consists of a smaller group drawn from the population. The method for calculating the mean is the same for both samples and population except for the notations. So if you are looking at the formula sheet that is in Blackboard, you should have that printed out and follow along with that, along with the notes that are in there. The notes are just the PowerPoints. The population mean has the symbol here, that's mu, and the sample mean has this symbol here, which is X bar. So when you see this symbol, mu, they're talking about the mean, but it's with the population. When you see this symbol, they're also talking about the mean, but it's with a sample. A list of numbers, which they designate by n, is denoted by x1, x2, ... xn. So this is just notation on a list of numbers. The sum, this is a summation symbol. That is a very important symbol. Whenever you see that, you add things up. The summation of xi represents the sum of these numbers. So the summation xi, that just means add up. If they give you 5 numbers, you add up all the 5 numbers. The sample mean is given by the sum divided by the number. The population mean is given by, again, the sum divided by the number. Notice that this is a small letter n for our sample, and this is a capital N for population. As an example, during the semester, a student took 5 exams. The population for the exam scores is 78, 83, 92, 68, and 85. Find the mean. So again, you add all the numbers and you divide by how many there are. And they're using the mu symbol because this is the population. So 78, 83, 92, 68, 85, add them up, you get 406, divide by 5, 81.2. Note that the mean is rounded to 1 decimal place than the original data. This is generally considered good practice. So again, they're just rounding to 1 place. The median is another measure of center. The median is a number that splits the data set in half. So half of the data values are less than the median and half of the data values are greater than the median. The procedure for computing the median differs depending on whether the number of observations in the data set is even or odd. If n is odd, meaning you have an odd number of data, just like the tests, there were 5 of them, that's an odd number. The median is just the number that's right in the middle. It must be in order. So the data must be in order. It doesn't have to be in order when you're doing the mean, but the median it does. If n is even, meaning like if there were 6 tests, the median is the average of the 2 middle numbers. Again, when the data set is ordered. During a semester, a student took 5 exams. Again, here are our exams. Notice they're not in order here, but when they list them out here, they are in order. So they get the middle number once they're in order, and it would be 83. 8 patients undergo a new surgical procedure, and the number of days spent in recovery for each is as follows. Find the median. So here we have 8. Again, they're not in order when they're listing them, but when they go to find the median, they then put them in order, and if there's 2 the same, like here we have 2 13s, they just list them twice. Since there's 8 of them, you take the 2 in the middle, which in this case is 15 and 19. You add them up and divide by 2, and you get a median of 17. Notice if you would have taken the 2 in the middle here, it would not have given you a 17. You would have gotten the wrong answer. So make sure you order them. A statistic is resistant if its value is not affected much by the extreme values, meaning large or small. The median is resistant, but the mean is not. So as an example of what they mean by this, they're showing 5 families have annual incomes of $25,000, $31,000, $34,000, $44,000, $56,000. One family whose income of $25,000 wins $1 million lottery, so their income now is $1,025,000. Before the lottery win, the mean and the median were as follows. So the mean was $38,000, so they added up 25, 31, 34, 44, 56,000, divided it by 5 and got 38,000. And the median, these are already in order, so it's just the middle number, was 34,000. Now after they win the lottery, what happens is we have a new number now. Instead of this 25,000, it now becomes $1,025,000. So you're adding $1,025,000, 31, 34, 44,000, 56,000. You're still dividing by 5, but this time the mean is 238,000, and the median is now 44,000. The reason the median went to 44,000 is because when you reorder them, you no longer have this one. So this is the 31,000 is the first one, the 34,000, 44, 56, but now the $1,025,000 is at the end. So now the 44,000 one becomes in the middle. So the extreme value of $1,025,000 influences the mean quite a lot, increasing it from 38,000 to 238,000. In comparison, the median has been influenced much less, meaning it went from 34 to 44. So that is, the median is resistant. The mean and the median measure the center of a data set in different ways. When a data set is symmetric, the mean and the median are equal. This is symmetric, so the mean and the median are equal. When the data set is skewed to the right, there are large values in the right tail because the median is resistant, while the mean is not. The mean is generally more affected by these large values, therefore the data set is skewed to the right. The mean is often greater than the median. So when it's skewed to the right, the mean is larger than the median. Similarly, when the data is skewed to the left, the mean is often less than the median. So here the mean is less than the median when it's skewed to the left. Or you could think of it as wherever it's skewed, right or left, the mean is closer to the skew. Another value that is sometimes classified as a measure of center is the mode. The mode of a data set is the value that appears most frequently. If 2 or more values are tied for the most frequent, they are all considered to be modes. If the values all have the same frequency, we say that the data set has no mode. 10 students were asked how many siblings they had. The results are arranged in order. So some people didn't have any siblings, one sibling, so forth and so on. Find the mode of the data set. So the mode is the number that's most frequent. So this number 1 occurs once, 2, 3, 4 times. So 1 is most frequent, so 1 is the mode. The mode is sometimes classified as the measure of center. However, this isn't really accurate. The mode can be the largest value in the data set or the smallest or anywhere in between. Means and medians can be computed only for quantitative data. The mode, on the other hand, can be computed for qualitative data as well. So again, we have a list of cars on a particular day. Which car is the mode? So again, you're just looking to see which name appears the most, and Toyota appears the most frequent, so that would be the mode. But you certainly couldn't add these up and divide by how many they were. That wouldn't give us any indication of anything. Weighted mean. A weighted mean is a mean in which some of the numbers count more than others. To compute a weighted mean, we assign a positive number called a weight to each number, and with the numbers that count more, get in the larger weights. So for instance, you're multiplying them all and dividing. Let's just look at an example. So we can see how this takes effect. Last semester, Joe took 4 courses. He got an A in statistics, which was 5 credits, a B in psychology, which was a 4-credit class, a C in English, which was a 3-credit class, and an A in music, which was 2 credits. So an A is worth 4 quality points, or like a 4 as a GPA. B is worth 3 quality points, and C is worth 2 points. Compute Joe's grade point average, or GPA. So the data values are the points for each. Grades are 4, 3, 2, and 4. The weights are the numbers of the credits, 5, 4, 3, 2. The GPA is a weighted mean. So we have statistics was a 5-credit class, and he got an A, so that's 4. The next one is psychology, which was a 4-credit class, and he got a B, and a B is a 3. The next thing is English, which was 3 credits, and he got, what did he get? A C in English, so that's only a 2. And then he got an A in music, so music was 2 credits, and an A is 4. So you go 20, 12, 6, and 8. You add those up and divide by the 5, 4, 3, and 2, and you get 3.29.